Hey folks, Tim Graves here again to take you through another little session on how to do stuff with Helidon. So what we've looked at so far is all about how you can do effectively REST enabling a service, how you put a security on a service and stuff like that. What we do need to consider, however, is what we actually do with our data. It's very, very rare that you actually don't do some kind of persistence with data. Right? Now that could be storing it in a database, it could be storing it in a file system, whatever. But in most cases, you do care about data persistence. So what we're going to look at here is how to store data in a database. Now, obviously, as an Oracle employee, it's really easy for me to get access to an Oracle database instance, so that's what I am using here. However, if you want to, you could change the configuration files here in the database drivers to use, for example, MySQL running locally, or basically any database of your choice that is supported by Hibernate. You'll need to update the POM file to include the relevant database drivers and so on. But for me, it's just easier to use one running in the cloud. And what I've done is, in addition to creating the database and creating a user in the database, I've also downloaded the database wallet file, which is effectively the access and configuration data that lets me then talk back to that cloud-based database service. So let's have a look at how we can do stuff with databases. Well, as before, this is pretty much standard. So we have a main method. This defines a set of configuration files to load and so on. Stuff that you would expect as we have used before, okay? And we also have our resources folder, and the stock resource is the thing that we're going to be really working on here, okay? So this basically is the microservice that will interact with our database. Now, one point here, this is a microservice, so we are effectively using this as an abstraction layer between any other service and the database. That means that if we wanted to, we could potentially update the database schema or add additional functionality, and we'll see how we might do some of that in a moment. Now, of course, if we do that, we don't want to have to change the calling code, and by abstracting it into a separate service, that lets us operate in that manner. Now, to start with, this is, again, pretty standard. We've got a path, it's request scoped. We're injecting some property values, and we're doing traditional, in this case, Java persistent stuff. So we are creating an entity manager, and our entity manager is based off the persistence.xml file. So this effectively specifies the classes that we want to put into the database. Now, I'm not going to treat this in detail as to all of the stuff that you do with persistence. Obviously, there's a lot of courses that will teach you how this would work. But basically, this is the configuration file. Key thing to note here is we're basically just specifying the configuration setup, okay? We're specifying what the data source is, so we know where to look for by passwords and so on. And we're also specifying the 3 classes that we're going to be using within the database. Now, for this lab, this was originally written whereby we had one database that was being used across multiple users. So what we're doing is we're actually, in part of the database code, in a hidden manner to the caller, dynamically inserting the user's identity in there. So we could have one database which lots of people are using, the same table, and effectively their identity becomes an extra part of a primary key. This is fairly standard type of thing, right? So the way you would use this, you would create a entity manager factory based on the name of a persistence unit. You then create an entity manager that you would store away. And then at various points in your code, for example here, if I want to create a stock item, I would see, using the entity manager, is there one already that has the same primary key? If there is, then we throw an error and behave, the appropriate error messages and so on. If there isn't, then we would go and create the new item, and we'd use the entity manager to persist it into the database.
Sorry,
this is all pretty standard database stuff. Okay. The classes themselves, again, as you would expect, they're standard database staff classes. So if we have a look at the stock level, I'm using Lombok annotations here to create all of the getters and setters. I'm telling JPA that this is a database entity, and this is the name of the table I want to actually store it in. What the column names are, the embedded ID, and so on. There's nothing here that, if you're familiar with Java database programming, is going to be causing you complexities or problems. Okay, so why would we do anything with with Helidon here? Well, Helidon is going to do a couple of things that make our lives easier here. Now, what we're going to do is we're going to use Helidon to inject our connection to the database. And this works really well. Now, Helidon MP, which is the microprofile implementation of Helidon based on Eclipse microprofile, really doesn't have a huge amount of work to do with databases. Helidon Standard Edition actually has a better database engine in that you can create a set of abstractions, SQL queries, and so on that are specific to each database, but they're kind of abstracted behind a database independent layer. We're actually using Hibernate here as the underlying database engine to do the work. You could, of course, have used Eclipse Link or one of the other persistence layers if you wished. Okay. When we want to access the database, however, we probably want to try and make our life a little bit easier. So we want to get away from things like creating an entity manager, creating an entity manager factories, keeping track of stuff, especially given that this is request scoped, which means that every time we call this, we're potentially creating a new entity manager factory. That's potentially a lot of work. So what we can do is we can get Helidon and the injection subsystems to automatically track this for us. Okay, so first of all, we're no longer going to create this by hand. Done. Okay, but where do we get it? Well, as you would expect, we can use the context and dependency injection systems to do this for us. So what we're going to do is we're going to put annotation on our entity manager, which is up here. And that annotation basically says to Helidon, effectively inject the persistence environment based on the name stock manager JTA, which comes from the Java persistence system. Now, if we needed multiple entity managers, Helidon will maintain a pool of them. The likelihood is actually under the covers, it's only using a single entity manager, and that's being reused in multiple ways in a multi-threaded environment, right? So now we've taken away all of, or potentially taken away the overhead of creating a separate entity manager for each class, and we've made accessing this a lot easier. All right, so let's go and try and have a look at this. Now, what I have done here is I have specified in the environment variables how to access the database. Okay, so if we have a look at this, you can see we've got all of the environment variables here. For pretty obvious reasons, I'm not going to show the database password, but you can see how these are then passed in. So effectively, we're specifying the data source of stock manager data source and so on. Okay, let's run the code. And hey presto, it goes and starts up. Now, one important point to note here, well, actually, there's a couple of important points to note. Firstly, this is running on a different port. This is running on 8081, because if we have the two microservices running in the same laptop environment, obviously there's a potential for conflict there on port clashes. Secondly, we don't start the database connection up until it is accessed. So this is very much a lazy initialization mechanism, okay? That can cause problems in that the first time you access it can cause a delay. So it may be that you want to force that configuration to start up when you run by maybe having a little piece of test code that just goes and triggers it. Okay, so let's go and make a request. So if we go back to our terminal, we're accessing a slightly different URL here because this is running on a different port and it's a different service. So if we access the stock level service, and you can now see in the console that our data pool is starting, Hibernate is doing its stuff. You can see my department is TG shop, and we've returned nothing. This is not a surprise as we don't actually have anything in the database. Shock horror. Okay. Also, you can see here that I've just set Hibernate to actually tell me what SQL it's running. It will also look at the classes and create database tables for me if they are needed. Now that's just a setting that I'm using for lab purposes to make life a lot easier. Obviously in a production environment, you would probably have that under a little bit more control. Now, we are actually using a slightly different way of accessing our classes here. or our URLs. So you can see previously that we had one URL that we accessed and we just used different methods. What we're doing here is we're putting information into our path. So effectively, the path itself becomes the data that is being passed into our code, right? This is slightly different from what we did before, where we put the request information into the body and that was processed as a JSON object. But we're still returning this as JSON. The only reason I'm doing this is just to show you that it's possible to do things differently. And just to show you here, you would then use a path param to say which element of a path gets mapped onto which method variable. Okay, now let's go and make a request. Now I'm going to expect this to fail. Those of you who have done Java persistence may know why it will fail. Of course, the copy and paste also fails. Let's try that. Okay, so I am basically saying do a put, so call the create method with the item name of pins and 5,000. And boom, as expected, it fails. If we scroll back in our code here through the large numbers of things, you can see that it's expecting a transaction. Well, for databases, transactions are pretty important, especially when you're making modifications to the database. So it's not actually that surprising that it's expecting a transaction. Now, we could use the transaction manager or the transactions in the entity manager and manage those manually by doing entity manager start and end transaction. And then we'd have to consider all of the possible cases where it succeeds or fails and do the rollbacks for us and so on. But fortunately for us, Helidon has a much easier way of doing this. What we can do is we can put an annotation on our code, which will tell Helidon to automatically wrap requests in a transaction and to commit those transactions or roll them back depending on how the errors happen. So literally we just put the @transactional annotation in place. Helidon is now going to create a transaction for us. If our method successfully returns, that transaction will be committed. If the method fails, then the transaction will be rolled back. So now if I save our program and run it, so again, we've got a short delay whilst it goes and starts up the database connection. And you can see here that actually we've done an insert into the data set, and we've actually got now a result saying we have 5,000 pins. Yay, go us. Well, as you would expect, that's pretty standard. If I try and go and add some other items, well, actually, no, first of all, let's go and get the level of our stock. So we can get the stock level data itself. So yep, we've got 5,000 pins. We can also call a specific method to say, tell me specifically what we've got in terms of pins. And again, that returns that level. So let's go and create some test data now. And we'll show, we can see what we've done. We're going to use this test data in other services as well. So let's run this lot. So that's going to create some pins, some more pins. We'll create some pencils. Okay. We'll create some erasers. Come on. Copy and paste, please. I do hate technology sometimes. There we go. And we'll create some books. Okay. Now, let's go and just see what happens when we try and create something with the same name, because obviously, you know, this is a primary key in the database. We would expect this to fail. So if we go and create 50 books now, it shouldn't actually add any additional books. It should generate an error. And in fact, if we scroll back and have a look at our database log file output, you can see we've got an item already exists exception. Basically, it's a duplicate item. Okay, so we can do that now. If we want to, we can go and get all of our stock. So now we can see all of the items that have been retrieved. Okay, and we can, of course, go in and retrieve specific items, as you would expect. Now, there's other things that this code does. It doesn't just allow you to create them. We can delete items. And you'll see here that what we're going to do is we're going to delete the pins. Okay, and you can see I'm using the delete method now rather than the put method. Okay, so this is just, let's say, pretend that we shouldn't have called them pins. We're going to call everything by its singular name, not its plural. Okay, so we've now deleted our pins, and if we go back and have a look at our stock level, oops, let's go back there. Come on. Okay, you can see that we only have pin instead of pins. Okay, so we can also change the level of the stock. So let's go in and we can see here that we have 200 pencils. Let's try seeing what happens if we change that from 200 down to 100. Okay, so yep, that's updated. It's returned the new value. And if we go and have a look at the whole set of data now, you can see that we're reporting 150 pencils. Right. So this is pretty easy stuff. You know, what we're doing here enables us to basically access a whole bunch of information and see how we can play around with the database. Okay, so we have successfully written data and read data from the database, but we might want to do something else. We might want to keep track of who's been playing with our database. Now, this is an optional section in the lab, but I'm going to walk you through it from a video perspective. What we've got in this class, in addition to methods for creating and deleting items within the database and listing them. We also have some routines here a little bit further down, which are audit routines. Okay, and what happens is you can see in most of our code that we have things like we'll generate a audit record. Obviously, this is within the transaction, so if a transaction fails, the audit record will also fail. So let's just have a look at how that would work. It's probably quite a useful thing to be able to do this. And it's something that you can just add within, for example, the database microservice without having to change any other piece of the code. So you can see here, this is an example of the audit data. Let's just go and get that again. Effectively, I'm making a call to the stock level audit system to say, go and give me the last 10 audit records. Now, interestingly, you can see here a whole bunch of information, but the operation user is unknown. So we know that audit records are being generated, we know that information is there, but we don't know who it is who's doing this. Now, of course, we do know to some extent because we've got the information in the request as to who the user is. So the question is, how do we get this information? And the answer is that we access it using the context. So whenever you make a request, you have context in your request. So let's go and have a look at how we would inject that into our request. So let's go and find the create method in here. Okay, so here is our create stock level method. What we're going to do here is we're going to add an extra item to that request on that method call. Okay, so you can see here what I've done is I've added a context, in this case a security context. Now there are other contexts if you, for example, wanted to get the HTTP headers or other things, the response and so on. But basically the security context takes information about the authentication and stuff like that that's been provided. Okay, and what we're going to do is we are then going to extract from the security context the name of the person who is making the request. So instead of it just being unknown, we're now going to say, look at the security context, get the user's principal, and then get the name out of that, right? And then further down in our code, we will then create a record using that. Okay, so what I'm going to do now is I'm quickly going to go and make that change to all of the other methods, so all of them inject for security context, and we'll be back in a second. Okay, so as you can see, I've done this on not just the get, but also on the put, post, and delete methods. So now, whenever you do anything that changes the database, we will extract the security context from that environment, and then we can look at it. Now, what I haven't done is I haven't changed this on the retrieve mechanism, because that's probably not something you would necessarily want to audit. Okay, so let's just stop the process and restart that. Okay, and let's then go and make a request, and we are going to put a new item into the database. Okay. Okay, so we're going to create some pies in the database. Okay, usual database connection work starts up because we've just restarted the service. Hey presto, we've got that. So let's go and get our audit record. So we're just going to get the 5 most recent items. And you can now see that the create method created operational user Jack. So effectively, we were able to extract that information from the configuration and from the request context. Now, there are obviously a number of other methods that you can use to get this. You can look at the request, for example, may be something you'd want to look at in terms of getting the headers and so on. Clearly, the audit mechanisms you would probably want to put behind a separate set of requests rather than just letting a general admin user be able to access them as well. Okay. Critically, do remember this is running within the same transaction, however. Okay, so what we've just done now is we've shown you how you can create a new microservice that will retrieve database information and process it. You can use that information or that microservice to access the database as part of a transaction. So you can just do this using the transactional annotation, and how we can update this microservice to access the request context to get more information about what's happening. In this case, we're transparently adding an auditing function that the rest of the microservices don't have visibility to. So thank you for that. What we're going to look at in the next section is how to connect the 2 microservices we've created together. What you've just seen is based on a lab, which goes through effectively using Helidon to create microservices from a monolith piece of code. This lab is available to anybody on the internet. It's originally written to work in the Oracle Cloud, but you can take the source code from the Git repository and run it in your own environment. You can use a MySQL database or other databases if you want to. So what I'm going to do now is quickly show you how to get to the lab. That will include links to where you can download the original template source code and obviously the content of the lab itself. So in a web browser, if you go to bit.ly/go-live-labs, okay, and that will take you to the Oracle Live Labs starting page. Then search for using Helidon to create microservices from a monolith. Now that's going to return 2 lab options. The overall sequence of videos is based on the extended lab version, but if you don't want to do the extended stuff, you can just focus on the shorter version. You basically just click the launch button. And then if you want to run it on an Oracle trial, you can register for free trial environment. If you already have a free trial environment, you can then look at running it within that environment. You just basically click on that. You can then have access to the web page. Effectively, what you need to do, follow the instructions under getting started and set up your tenancy and set up for the Helidon Labs to get this working in the Oracle Cloud environment. Now, if you don't want to use the Oracle Cloud environment, then there are instructions on how to download the source code using in the setup for Helidon Labs section. You'll obviously need to make sure that you've got Java 11 on your laptop. You're going to need to make sure that you've got a suitable IDE and so on. If you want to use a database other than the Oracle database, you can do that, but you'll need to configure the database files so that you can ensure that it will work on the local database, and that's basically through the JDBC and JPA, JTA settings in the meta-inf folder. So thank you for that. Hopefully you will enjoy playing with that, and good luck.